Baik, selamat pagi semuanya. Tidak terdengar. Selamat pagi Bapak Ibu dan teman-teman peserta semuanya. Baik, selamat pagi Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom, namo buddhaya, salam sejahtera, salam kebajikan dan rahayu. Selamat datang kembali di Hotel Grand Santi Denpasar, atau bagi teman-teman atau adik-adik mahasiswa selamat datang ya di Yudhistira Room Grand Santi Hotel Denpasar. Dan hari ini adalah hari kedua kita ya, dan hari terakhir untuk acara atau konferensi Science and Technology International Conference 2025. Kita boleh beri tepuk tangan adik-adik, Bapak Ibu sekalian. Kita sudah memasuki hari kedua dan mungkin apa kabarnya hari ini? Baik, sehat, walafiat ya. Kita bisa berkumpul dengan sehat walafiat di sini. Terima kasih kepada Tuhan Yang Maha Esa ya, Bapak Ibu dan teman-teman mahasiswa. Dan semoga Bapak Ibu serta teman-teman mahasiswa mendapatkan istirahat yang cukup dan lebih bersemangat lagi hari ini ya untuk melanjutkan plenary sesi ketiga. Dan juga nanti di akhir akan ada parallel sessions di breakout room di luar ya. Masih di hotel yang sama. Dan sebelum kita memulai sedikit beberapa pengumuman. Adapun sertifikat peserta nanti akan dibagikan pada hari ini. Jadi kami menyarankan sekali dan mewajibkan untuk tetap mengikuti ya. Mengikuti kegiatan hari ini. Dan mengikuti keberlangsungan acara hari ini, dan sesi paralel juga akan dilaksanakan setelah selesai plenary sesi ketiga, begitu ya. Dan ya, kita akan memulai plenary sesi ketiga. Dan apakah sudah siap semuanya? Sudah? Apakah sudah siap Bapak Ibu teman-teman? Sudah ya, oke, baik. Oke, we will proceed to the next plenary session, the last plenary session for today, and the third plenary sessions with the speakers including Professor Dr. Shakir Ali from Aligarh Muslim University, India. He will be joining us online ya. Selamat pagi, good morning Professor. And we also have Dr. Calvin Mpofu from University of South Africa. And this session will be moderated by Insinyur Ibu Igusti Ayufida Mastrika Giri. And our moderator today, a glimpse of our moderator for today. She is a dedicated researcher and lecturer in a computer science with 9 years extensive experience in machine learning, deep learning, and music information retrieval. And currently investigating EEG-based classifications using deep learning techniques. And she also holds a master degree in computer science from Universitas Gadjah Mada and has published multiple peer-reviewed papers on EEG classifications, music recommendation systems, and AI applications. Therefore, to Ibu Fida, the stage is all yours. Boleh beri tepuk tangannya?
Good morning. Hello. Okay, welcome to this morning's session of the Science and Technology International Conference 2025. My name is Vida, and I have the honor of moderating this session. In this session, we will hear from two distinguished speakers joining us online, who will share their latest research in mathematics and physics and their connections to emerging technologies. Before we begin, let me first greet our speakers. Good morning, Professor Dr. Shakir Ali. It's a pleasure to have you both with us today. Okay, Okay, it's great to hear you clearly. Okay, without further ado, we'll proceed with our first speaker. I will introduce you to our first speaker first. Our first speaker is Professor Dr. Shakir Ali, Professor of Mathematics at Aligarh Muslim University in India and adjunct professor at Universitas Gadjah Mada in Indonesia. He also held visiting positions in several countries, including Malaysia, Turkey, the USA, Slovenia, and South Korea. Prof. Ali has more than 25 years of academic and research experience. He has published over 160 research papers, written several books with international publishers, and presented at almost 100 conferences worldwide. His work has been widely cited with more than 5,000 citations on Google Scholar. His areas of expertise include algebra, coding theory, cryptography, and functional analysis. He has served as a full professor at Aligarh Muslim University since 2019. Before that, he was an associate professor at AMU and KAU. He has also worked as a senior assistant professor and lecturer at Aligarh Muslim University. Prof. Ali's research output is remarkable. He has over 160 journal papers and 3 books with Springer, CRC Press, and Cambridge University Press. He has delivered more than 90 invited talks and contributed to numerous international collaboration. He is also involved in mentoring the next generation of researchers. So far, he has supervised 1 postdoctoral researchers, 6 PhD graduates, and 2 MPhil students, with 5 PhD students currently ongoing. He has also guided more than 17 MSc projects. Prof. Ali has received numerous international honors. He was awarded a Tubitak Visiting Fellowship. He received the Outstanding Scientist Award. He has also obtained several national research grants. Okay, Prof. Shakir Ali, we are pleased to have you with us today. You have around 25 minutes to present. The screen is yours.
The slide first. Yes, the slide is visible.
Yes, we can see the slide.
The slide is visible.
Yes, we can see the slide.
Yeah, I can see the slide.
One minute, I just want to make more. Now it is okay. So, dear friends, today's I will talk about the role of mathematics in science and technology in the light of present scenario. So let us begin with journey about the mathematics in the view of different scientists across the world. So let us mention the quote by very famous analyst Stephen Banach, what he said about the role of mathematics in science and technology. According to him, mathematics is the most beautiful and most powerful creation of human spirit. So this is the view about the mathematics by very famous scientist you call mathematician Stephen Wanach, and about the another scientist who has background in the information science. According to him, mathematics is the foundation of information science. It transforms data into the knowledge and algorithm into the innovations. And his core really work in the present time, in the age of this digital era. In the light of another famous scientist, Linus Pauling, according to him, without mathematics, there is no way to express deep harmony of chemical reactions, molecular structures. So these are the most important branch of natural science where they mention about the role of mathematics in his own view. According to my view, mathematics is the way to express everything. Because without mathematics, on the other hand, if we start our journey since morning to evening, we start our day with mathematics. As already you know, when you wake up early in the morning, your first hand is you will look towards what is time. So that means we start our day with mathematics. The importance of mathematics is count and imagine by the thoughts of these great scientists in all the spirit of science and technology. So let us begin our journey about giving some brief account. Just mention how we'll proceed. In first part of my talk, we will give you introduction, that means connection of mathematics, little bit background, and discuss few applications in coding theory and cryptography, most important branch of information science. Okay, and let us move to then. Ajit? What? One minute, I think there's some. Sorry, this is, sometimes what we have. So we are not, this is what drawback of in my, the of things means technology, sometimes work and sometimes it's not, it is not in our control. However, we use and we can do great things. Sometimes it is out of control, like now. Okay, so dear friends, let us give you some, the background, how mathematics play the role in natural sciences. Okay, so mathematics serve as the foundation of natural sciences. It provides a language to analyze, predict, understand complex phenomena in physics, chemistry, biology, and so on and so forth. As far as concern the role of mathematics in physics, that lie the mathematics equations describe the natural laws and laws which are the foundation of physics. That from Newton's law of motion, Newton's law of gravitation to the Einstein's theory of relativity. Dear friends, if you look how to create the importance, mathematics, the whole physical phenomena will understand easy with the help of, the mathematics. So I just give you the example. If you go look at, uh, Newton's law of gravitation in term of mathematics, so look at here, if you have a like this, if we have 2 point, like you have 2 point here, so this is a bit of M1, M2, how the force we apply. So this force in fact are directly proportional to M1 cross M2, and this is R squared distance. Okay, so you look the behavior of this physical phenomena, how we understand. So if you want to write, then you can write down this F is equal to G, that is called gravitational constant, and M1 M2 upon R square. So this means what? The F is directly proportional to the product of the masses and square of the distance between these 2 points. So to understand its whole the behavior, how the universal gravitational law will work, follow the mathematical equations. And this is the way which shows the importance of, this mathematics in the light of, uh, gravitational law. Similarly, if you look on the other role in chemistry, so if we go for the chemical reactions, like, how we can make balance to the things and chemical reactions. So for as far as the third point is concerned, the chemical reaction was a model using many type of, the differential equation, sometimes the balancing of the equations, and so on and so forth. For example, if you look for the organic chemistry, then look this example very important. Just 1 minute. So it is better to understand. That is, if you have the CH4 and combine with oxy O2 and look its balance position, how it will look CO2 plus and SO2. So this, how these things have connection with the mathematics. So if you want to talk the balance of these chemical equations, so you can thought about the mathematics. So this is the second example about the role of mathematics in the chemistry. On the other hand, if we are talking about the biology, I give the best example later on where we use the mathematics in medical sciences through the DNA computing and DNA structures. We will discuss later on because we already have a lot of work in this area in the role of mathematics in biological sciences. We discuss later on. And then if you talk about the other things like information science, so now already the
No.
Huh? Then we come on another part, which is most important in the present scenario, that is the role of mathematics in information science and technology. So mathematics form, I am audible? Hello? Hello?
Hello?
Hello.
Yes,
Yes, I can
please
hear you.
keep in touch, okay? So if there is any question coming on the first part, please feel free, okay? And now we come on role of mathematics in information science. So as the second core, the mathematics form the cornerstone of information science. Encompasses the field as coding theory, cryptography, machine learning, and signal processing. For example, the coding theory ensures the error-free communication through the algebraic code. And that part basically gave you the detail in my middle part, because we use most of the abstract algebra in coding theory, and we describe kind of codes which are important in coding theory. Basically, coding theory is the most important branch of information science, in particular modern algebra, okay, that will be used, that we call algebraic coding theory, that deal to sending the message from one place to another place, we call coding theory. And the important role of mathematics in the coding theory is vital. Lot of things will be depend on that. This give you example later on. And then we come on cryptography. So the cryptography part, the heart of information science, that send the message from one place to another place in the secret. Nobody can see in the middle way, or nobody can hide. So that was another part of modern algebra has ruled in information science. We used many, important algorithms from mathematics in cryptography. And in the present time, already the data science, machine learning are the important part of the digital technology, and mathematics, in particular linear algebra, okay, is play vital role in machine learning and the data science. Another example, if we talk the neural network in the brain inspired the mathematical models use the artificial intelligence. This but also use the modern linear algebra as a tool for neural network in artificial intelligence. If we talk about the medical sciences, so the last part, if you have like that is called basically how image processing, and other words people are using, meaning how you can look the images and see the behavior of diseases. Okay, that was very close related part related to mathematics, where we use the Fourier analysis for image compression, like JPG files. Okay, so and audio filtering in MRI and CT scanning in the healthcare system. So in every way we look the use of mathematics one way, another way. And now, basically, I an expert from algebra, because mathematics has lot of things in various part of the branch, several part of science and technology. So it is not possible we will give you the whole information in this, the 30 minutes. So I decided just take one particular example to show you which part is most important in the light of present scenario, that means digital technology. So in abstract algebra, basically we use the ring in both, in information science as the fundamental tool in information science. So basically, what is ring? Just we are give a brief account, then we come on the other part. So ring is a set of, set with two binary operation, addition and multiplication, satisfying the following law. This R under addition is an Abelian group, and R under multiplication is associative. That means the associative law will be whole, like here. Okay, so if you look at that, so and then both distributed law whole. This is basically one of the algebraic structure deals with two binary operation. And then you have very famous and classical example, set of integers. Okay, that is the ring basically, and most important, this is infinite set, and that the ring which has infinite number of elements is called infinite, otherwise we call finite ring, because this ring, our next few slides play important role. So please keep on that. What is ring of integer? Because this is the backbone of information science. Okay, where we use the finite ring, but we construct these finite ring through this infinite structures. And then there are kind of rings, but we're not going details. Like a ring is called a ring is with identity if the following law is satisfied. That means A is equal to E, A is equal to A for all A belongs to R. Okay, and that kind of ring commutative, which satisfy the commutative law. That means A into B is equal to B into A. Okay, so these are the few somebody in this is going in more detail. There is commutative, non-commutative ring. So this basically example of the ring. Okay, and of course this is 2 by 2 matrix ring. So it is always non-commutative. But first one is commutative. That means ring of integer is commutative. Now we will not go. Then we come on what we call field basically. So field is a ring in which the non-zero element under multiplication form a group under multiplication. So that is because if you make a difference, so the field is a structure where the inverse of each non-zero element will exist. So that make more interested in the light of science and technology. Okay, field means the non-zero element has multiplicative inverse. That means if you have the element, because this is very important when we will go to in that part, like if you have a element A belongs to F and definitely this is non-zero, then this gives you 1 upon A that we call A inverse also in F. That means, good sense of understanding the importance of field. That means each non-zero element has a multiplicative inverse. So this make its special, name and used in this present era. Okay, and then if with this, then we have another problem. We will just delete and we come on not give the more examples, but go because we not have enough time. Okay, so we will move another part. That means we are moving to the construction for a base field, base ring that are backbone of information science. So let us begin by the example. As you have the ring of integers, we already mentioned Z that has infinite number of elements, and we are going to construct a finite ring. And how we can construct through the mathematical tool that is called equivalence classes. So basically from this finite ring, we construct, this infinitely, we construct this finite ring, Zn. That means 0, 1, 2 up to n minus 1. So definitely this ring has finite number of elements, okay? But the operation is little bit different. What are the different operation? Look at here carefully. Okay, we already mentioned here these, if you have a two element in that say, and the addition is defined addition modulo n. Basically, n plus b is equal to a plus b mod n. This means if you divide a plus b by n, what is left? That's its value. Similarly, we have additional multiplication modulo n relation. So under these two new operations, this is finite ring of order n. Okay. So if this is a finite ring, let us just give you quick examples for those who are, means for the students. How you can do that? So take n is equal to 5, and a is equal to 3, b is equal to 5. Then how to combine a plus 5, a plus b? That means 3 plus 4 mod 5. So 3 plus 4 means 7. And we are talking about mod 5, divide by 5. So we write it 5 plus 2. Okay. So 5 means 0. So that 7 can be break as like 7 mod 5 is equal to 2. Similarly, if you a into b, that means 3 into 4 means 12. Divide by 5, again you have remainder 2. So this type of calculations will more interested and more important for security regions. So people will not easily can catch what is going inside in algorithms, like in the coding theory or in cryptography. For example, if you're dealing with your net banking, so sometimes you are doing these calculations, you will put your password, and again you will get information from bank, that's the OTP. So how to make secure this? So people cannot, they find your password. So that makes sense. So try to make more and more complicated things. That by we use a different operation, not usual addition and usual multiplication, we have something more to make things more secure for a security point of view. So we do such kind of things for this purpose. In that region, we do like that. And the whole scenario is like, the things will depend on equivalence relations. And equivalence relations, already we have a non-empty set as, then binary operation satisfy these two conditions: reflexive, symmetric, and transitive. Reflexive means A related to A is equivalent to itself. Symmetric means A and B in S. If A related to B, then B is also related to A. Such type of operation, the property is known as symmetry. Transitivity, like if A related to B or A equivalence to B, then B also equivalent, and B equivalent to C, then A is equivalent to C. So if any set together with this condition is called equivalence relation on that set. Through this, we construct equivalence class basically, and these equivalence class defined by this notation. Okay, this notation like A means X belongs to X, where X is equivalent to A. That makes sense, and that will give you the finite.
Excuse me, Professor. I just want to kindly inform you we have about 5 minutes left for your presentation. Thank you.
Okay, don't worry, we will do this. So with the help of this classes, like we construct this equivalent class of 0, 1, 2, and with this, and then we have like that, this element. So basically, this is the way, look at the definition. For n belongs to positive integer, and A is the integer, and the equivalence class of modulo n is the set X belongs to Z, where X is congruent to A mod n. Basically, this class gives the finite ring, and that Zn that collect 0. But this is the not just as 0, but this is the equivalence class. Okay, so these are the n numbers. So this n will give you the finite ring or finite field depend on n. And with this form, the finite ring and depend on, so this is what meaning of the equivalence class of zero. So this equivalence class of zero consists of infinite number of such kind of elements. For example, if you look on for n is equal to 3, so you have 0, 1, 2, 3. Okay, so the equivalence class of 0 has 3 elements: equivalence class of 0, equivalence class of 2, equivalence class of 2. Like this one. So for the simplicity, we write Z3 like 0 bar, 1 bar, and 2 bar. Dear friends, this is why, because this 3 is finite and this is prime. Basically, this is the field and field of order 3. So that field, that kind of fields people are using in, the information science. And most important field that was used in information science is depend on this one. Okay, the finite field in information science and technology. For n equal to 2, we have Z2 like 0 and 1. This is the field, or this is the ring, has different names depend on the area. If you call this is the Boolean ring in light of algebra or Boolean algebra or in electronics engineering. Okay, this is Galva ring in the light of abstract algebra. This is the ring for communication, algebra for communication like coding theory, cryptography, information science. So it has a different meaning. If you look at define these operations, addition and multiplication. So this is the table, okay? And this for the multiplication table, similarly, this is multiplication table. However, if you add like 1 plus 1, so this 1 plus 1 basically is what? This is not same as what we expect, okay? So this is, already, this is 1 plus 1 is 0. So this is calculations are over Z modulo 2. So this is the things only the programmer know what are the operations. So that class of rings or class of the field are backbone of information science. Okay, and that will be the most important part of abstract algebra, and which play the significant role in information science and technology in the present scenario. Dear friends, let us, because don't have much more time to explain, let us come on few kind of work, my work related to this area. So we come on give you some relation to the coding theory. As I told you, the coding theory is the study of method for efficient and accurate transfer of information from one place to another. Okay, so where we use this, what we just talked. Okay, so look at the examples. Specify. So this is the what, how we transfer the message, what kind the message, then what you will get exact message, sometimes not. Like I am talking to you, maybe some problem in the middle way, so you will not get exact message what I'm talking now, or sometimes you will get the late notice the picture, what it will take little bit time when we reach to the audience. So this, why this happens, because of there is a noise in the middle bay, so that is called error basically. So how we correct this error, and so you will get the correct message, that branch is called cryptography. So we use that in like here. So the coding theory is integral to the satellite communication system, because it enables to reliable data transmission in the presence of noise, interference, and other singular impairments. Basically, the satellites operate in the environments where the signal degradation is common, making error detection and correction crucial. Error detection and correction transmit data over the vast distance, and the signal are often corrupted. And already the cosmic noise, atmospheric interference, and then hardware imperfection, error correcting codes. Like so many, the problems in the middle way. So we correct this through such kind of mathematics, especially in algebra. Okay. So if you look very particular example, okay, mathematics in the coding theory. So algebra in the coding theory, if you look my field, so this is the field of order Q, that means finite field of order Q. So what is the course which are connected to the coding theory with the information science? A linear code C of length n over IFQ means the finite field of order Q is a subspace of this ring. Okay. So look at the element 0, 1, 1 like that. Okay, so they are the backbone of information science. So but depend on finite ring. And then similarly the other things, but we not go in detail. Let us give you more precisely how to play algebra, most algebra role in this area. Like then we take the polynomials. Through the polynomials we find a new code like this C generated by this polynomial. This is basically the ring F2 over quotient ring. Okay, this is the the polynomial of degree 7 eligible. So means such kind of things we using deep mathematics, okay, in information science. And let give you the my work in the light in the area of science coding theory. So these are the recent publications but just published in design course and cryptography, most important journal in Spencer, where we discussed totally algebraic tools to find the constant cyclic codes over general alphabets by using purely algebraic codes, not the other one. And then this one, another we have references. If somebody are interested, please write me. So we will go send you the more detail. There's a lot of things is going on in the role of algebra in information science, particularly in coding theory and cryptography. And then we come on, just give you the highlight of the cryptography, not detail, but just, uh, example. So the example, this is what the coding cryptography, sending secure message from one place to another place, not go and then give you the importance. See, here again, you have a matrix over finite field. Okay, like Z3 again, we have finite field, then we construct matrix, and we construct the MDS. MDS matrix means a matrix which has every square sum matrix is non-singular. So this matrix has the base in finite ring or finite field. Okay, so not go on. Let us come on another the recent result in cryptography based on algebra. So these are the results, some research, the role of the abstract algebra in cryptography. Okay, and this is my, if you want to see, BF5 reference 5, that was the applicable algebra engineering and communication computer. So these are the results where we use the abstract algebra in cryptography. And then we not go in much more detail. Application in graph theory, one of the more, but we not go because we not have time. So we will leave and we will move, like again, these are the base of ring theory, but not again, you see, this is G4. G4 is the finite ring. How we finite ring play important role in graph theory. Okay, so see the structure and the base from the rings, but we will just not go and we are going to conclude. So again, we have, the field and then find the Cartesian part of the field, and that gives the zero divided graphs, these important graphs, which has very close relation in chemistry. Okay, how to represent the moleculars through the mathematical, the structures are modeling, or you can say the how we use the abstract algebra in chemistry. So this is what structure. This has close connection, related to the ring theory. Ring theory, that means Zn. Okay, so this is the structure represented by infinite ring. So these are the some recent again from the algebra in graph theory. So with this, we are going to complete, and thank you very much for your kind attention. Yes, please.
Well, thank you,
Can I
Professor.
stop the sharing?
Yes.
Okay.
Thank you, Professor Sakir Ali, for your inspiring presentation emphasizing the fundamental role of mathematics. We truly appreciate your valuable contribution to this session. We will have time for discussion after both talks. Our second speaker is Dr. Kelvin Mpofu from the Council for Scientific and Industrial Research, or CSIR, South Africa. Dr. Mpofu holds a PhD in physics, focusing on quantum biosensing. He also earned his BSc honors and MSc degrees in physics. His main research interests include quantum optics, quantum sensing, quantum computing, and machine learning, particularly their application to medical diagnostics and advanced photonic technologies. Dr. Mpofu is unable to join us live today, but he has prepared a recorded video presentation of his talk. Let's now play the video presentation from Dr. Mpofu.
Good morning, everyone. My name is Kelvin Mpofu. I am a senior researcher at CSIR in South Africa. I'm also an emerging research leader under SAPUTI, which is the South African Quantum Technology Initiative. And today I'm going to present my talk titled Current Research Progress on Quantum Enhanced Diagnostic Platforms for Real-World Healthcare Challenges.
Thank you, Dr. Mpofu, for sharing your insightful work through the recorded presentation. Now we will continue with the discussion session. Although Dr. Mpofu is unable to join us live, we are pleased to have Professor Shakir Ali with us to share his insights and respond to questions. Professor Shakir Ali. Professor Shakir Ali, are you still there? Okay, Professor Shakir Ali, glad to have you back here. Now we are in the discussion session, and we are glad for you to have a discussion with us. Now we will ask some participants to raise your hands to ask questions, and please remember to introduce yourself first. For the first session, we will have 2 or 3 questions. Are there any questions from the participant? Please raise your hand. Yeah.
Testing. Okay. May I introduce myself? My name is Jason, and thank you, Professor Shakir Ali, for the presentation that shows the importance of mathematics in science, no matter it's biology, chemistry, and coding, and especially in physics. But I have like a question. As like we know, you presented like the importance of math in all of the part of sciences, natural sciences. However, do you have any insight or advice to maybe, let's say, like there are some researchers or maybe students who sees mathematics as a scene of horror instead of a beauty? Do you have any insight or maybe like advices how to like change that kind of mindset that sees mathematics as beauty instead of a eldritch horror? Thank you.
Thank you. Professor Shakir Ali, would you prefer to answer the question one by one, or take all questions first and answer later? Okay, can you please answer the question first then?
My question, what is coaching basically? Could you explain what is coaching?
My question is, okay, in short, how to, do you have any advices or maybe insight how to change like the mindset of how to make math as a beauty? Like it's a beautiful subject, instead of like something we're scared of.
The best example, you are speaking in Indonesia and I am listening you from India. The best example is the beauty of mathematics. Yes, this is what. It is not possible without mathematics. So that means the mathematics, if...
Hello?
Sorry, Professor Shakir Ali. So maybe we wait. Maybe the professor have difficulty in internet. connection. Okay, we will wait Professor Sakir Ali to return to our Zoom meeting. So the question from Jason is, how can we change our mindset?
Also advices from Professor Sakir Ali. Like, I understand that it's like a different in Indonesia and India in culture.
Yes.
But as someone who know, like, who's seen, like, I teach some students and I saw, like, I have friends. When I talk about the mathematics, they are very scared,
Yes.
and to the point that they want to avoid the subject at all. And I want to ask for advice from Sakir Ali, how to maybe like an insight, or maybe like the basic, how to like change like from the mindset to seeing math as something is beautiful. It's not like something scary. I am sorry if maybe like there are profanity or maybe there are some words that is not correct during the question.
Yeah. Okay, we will wait for Professor Sakir Ali to return to our Zoom room first before he can answer the question.
Yes, thank you.
Okay, before the professor return to our Zoom, are there any more questions for Dr. Yeah, from the back. And I need one more question. Okay, yeah. Maybe we will keep the question first before the professor come back to our room. Please keep the question first, because the professor hasn't come back to our Zoom meeting. Yeah, so we have now 3 questions for the professor. We need to wait for the professor to return to the Zoom room first. Thank you. Okay, it's glad to have you back here in our
sorry.
Zoom meeting.
Sorry, it was disturbance.
Okay.
Yes.
Please answer directly the question.
My answer for the first question there. Do you got the answer of the first question? Hello?
Yes, Professor. Hello?
Do you got the answer of the first question regarding the role of mathematics in the present scenario? Okay. because I told you that you already, because you are in India, I am, because we are talking to each other like in one room. There is could you, I think, ask the participants to unmute, please. The voice is not very clear.
Oh,
Now, okay?
now, yes,
Is
it's not
okay?
clear. Okay.
Okay. So my answer is the role of mathematics in the digital technology or in information science in presently. Like I am in India, you are in Indonesia, but we are talking each other like we are in one room. This is the best example for the importance of mathematics in information science.
See. Oh,
Like
yes.
Zoom, Google Meet is the best, the tool used for the, lecturing, discussion throughout the world, and where we use the modern algebra, abstract algebra. Okay, so this is the best example for you.
I see. Yeah, I understand.
Any other question? Next one.
Oh, no, it's quite clear. If I'm gonna like tell the context of my question, if you may, just a bit, because not everyone see math as something as a beautiful or important subject. They know it's important, but like we know it's important, but some people are scared of math and they're do not willing to learn. Yeah, so like I want to ask for your advice or insights or your opinion about that. But however, your answer is clear, and I will like give the mic to the others because there are other participants who wants to ask for questions. But thank you for your answer, Professor Shakir.
One more remark.
Hmm?
Those who are in the room, everyone has the mobile in their hand. Okay?
Yes.
And we are using, you if you want to more attractive, so this is the mobile. And think about what role of mathematics in the mobile is the best way, okay, to motivate you. The use of mathematics in the mobile in the present scenario. Okay?
Okay.
Okay, thank you for the answer, Professor Sakir Ali. Because of the time, we have one more question from the participant. Please send the mic to the back.
Yes. Thank you for the chance that's given to me. May I introduce myself. My name is Professor Rawan. Currently, I'm studying for I'm actually from studying bachelor degree with mathematics program study from Udayana University. Good morning, Professor Sakir Ali.
Good morning.
Yes. I'm sorry speaking English is not good. Jadi di sini saya izin pakai bahasa Indonesia. Jadi di sini saya tadi menyimak topik dari Bapak Profesor Sakir Ali, yaitu topik peran matematika dalam sains dan teknologi. Di sini saya bertanya pada kasus penerapan di satu subtopik yang menurut saya penting untuk diterapkan pada bidang sains dan teknologi, yaitu kriptografi kurva elliptic atau STIC yang pada masa generasi algoritma kriptografi yang baru ini untuk dirancang mengamankan data dari serangan kuantum di masa depan. Pertanyaan saya, Bapak, mengapa algoritma kriptografi short itu membuat struktur aljabar atau STIC yang meliputi medan hingga logaritma listrik yang tidak aman, dan mengapa struktur fikisi elektris menjadi solusi yang mandatori? Terus apa saja tantangan matematis kritis yang termasuk efisiensi, keamanan oleh penerapan kriptografi berbasis ellipsis dibandingkan dengan STIC? Terima kasih, Bapak.
Okay, thank you for the question. I will try to translate for the Professor Sakir Ali. It's the question is about cryptography,
Okay.
right? and why the structure is important to use. And the student asked about the comparison of two cryptographic structure,
Yes.
right?
Right.
And which is better, right?
Right.
Okay, Professor Zakir Ali, can you answer the question?
Basically, which crypto system they are talking? I think he can repeat the question, which crypto system? The crypto system depend on the researchers. Okay. So which crypto system are talking? Which crypto system you are talking? Please, could you give the idea which crypto system you are talking?
Sistem apa yang tadi dibicarakan?
Please speak in English so I understand.
I will try
System-
to translate.
Sistem kriptografi kurva elliptic SCC.
ACC.
Ya.
Yes.
And other one?
Bagaimana penerapannya dalam membuat struktur aljabar SCC
And
yang
how
tidak
to
aman.
implement the structure to
Aljabar.
algebra structure.
Terus tantangannya secara matematis untuk mengintervensi keamanan data itu seperti apa?
And the mathematical challenges to implement the structure.
Yang ditimbulkan
And
oleh kriptografi berbasis elliptis dibandingkan dengan SCC. Perbandingannya, Pak. Elliptis
can you
dibandingkan
repeat the
SCC.
structure, both of the structure slowly, please?
Ya, perbandingan yang ditimbulkan oleh penerapan kriptografi dari berbasis elliptis dibandingkan dengan SCC. Perbandingannya gimana, Pak? Kriptografi elliptis.
Leptis
Yes.
with ACC.
Yes.
Okay. The comparison of leptis cryptography and ACC. Okay, do you hear it clearly, Professor Zakir Ali?
Yeah.
Okay, thank you.
Yes.
Thank you.
Yes. Oh. Basically, in the present scenario, why we are talking the latest, the answer is latest based crypto system is the best one. Why? Do you understand? Latest theory based crypto system is the best one. First thing. Clear? Okay. Now, why the latest based crypto system is the best one? Because in coming time, okay, when we have this supercomputer, then the three that is related to the so the lattice based crypto system is the best one, as I think. Yes? Do you understand?
Well, okay, thank you for once again for Professor Zakir Ali and Dr. Kelvin Mpofu for your valuable and inspiring presentation. We also extend our appreciation to all participants for your attention, question, and active engagement in this session. We hope you found the discussion insightful and enjoy the rest of the conference. Good morning.
Thank you very much. Can we have a round of applause for the last plenary session? Thank you very much, Ibu Fida. You're doing amazing. And thank you very much to Professor Dr. Shakir Ali, all the way from India, to give us his expertise on these sessions. And for the insightful sessions, Ibu Moderator, please kindly remain on stage, or please you can stand up here at front, as we will be presenting a token of appreciations for you. And we would like to invite Dr. Insinyur Agus Sanjaya, Eskom MCom, our Vice Dean and Planning Academic Affairs, to come up on stage, Bapak, to deliver the certificate of appreciation, as well as our speakers who is joining online. Silakan Bapak. And Professor Dr. Shakir Ali, we will be delivering your certificate all the way to India, online certificate, ya. Thank you very much, Ibu Ida, Ibu Fida, dan juga Profesor Dr. Shakir Ali. Terima kasih banyak Bapak dan Ibu Fida, silakan kembali ke tempat duduk. And once again, on behalf of the committee, we would like to express our immense gratitude for your expertise and knowledge sharing, and we hope the discussion will bring great benefits and impact to all of us here. Can we have a round of applause again for the energy today? And yes, that is the end of our plenary sessions, ladies and gentlemen, Bapak Ibu dan juga teman-teman mahasiswa. Dan thank you so much once again for your participations, commitment, sudah berdiri di sini sampai akhir acara begitu ya. Ini bukan akhir sebetulnya, karena akan ada parallel sessions nantinya. Dan your contributions to the remarkable plenary sessions and discussions for today, and hoping the insights and knowledge from our speakers, our expertise from all of the speakers will enhance and diverse your perspectives. And for your information, Bapak Ibu dan teman-teman mahasiswa, sekarang kita akan beranjak ke claiming certificate dari peserta. Jadi teman-teman mahasiswa, Bapak Ibu, ini ada QR code ya di depan, bisa di-scan dan diisi formnya. Setelah itu dimasukkan emailnya yang benar ya, nanti otomatis sertifikatnya akan masuk masuk ke inbox email Bapak Ibu dan teman-teman sekalian. Jadi bisa difoto sekarang dan juga di-scan. Kalau tidak ada kuota, ada wifi di sini, silakan dimanfaatkan fasilitasnya. Dan baik, setelah sudah selesai QR code, kita akan lanjut ke parallel sessions nantinya, dan untuk nanti akan di-guide langsung oleh Bapak Ibu panitia. Bagi teman-teman yang akan bertugas di parallel sessions, ada breakout room nanti tepat berada di luar dari Yudhistira Room ini. Untuk itu saya close karena planningnya sudah selesai. Terima kasih banyak Bapak Ibu dan teman-teman, boleh tepuk tangannya untuk sesi kali ini dan juga kemarin. Terima kasih banyak. Dan saya Dayusita pamit undur diri untuk mengisi acara dan selesai pada acara Yudhistira Room kali ini. Terima kasih banyak. Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. Shalom Namo Buddhaya dan Rahayu. Terima kasih.